So we're going to change gears just a little bit. We're going to step away from trusses for a couple hours. We will come back to them tomorrow, don't worry. But we are going to talk about relationships here. We're going to talk about variation. And two variables can vary with each other in one of two ways. The first way we're going to talk about is directly. So direct variation. And in direct variation, when one number gets larger, the other one has to get larger in a proportional manner. Or one gets smaller, the other one gets smaller in a proportional manner. So direct variation takes on one of two forms. Either the ratio of x divided by y is a constant, or y over x is a constant, however you want to look at it. Or y is equal to a constant times x, like that. Obviously, the constant would be the same. Actually, it would work out the same if I did this. If I made this y over x instead of x over y. Those are just different formulations of the same equation. You can solve one to get the other. Typically, we will use this setup. But if we're comparing situations, we'll use this setup. Direct variation is what we call proportional. So if we say that y varies directly with x and y is 42 when x is 7. What that is telling us is that we have a direct relationship here. First part we have, y varies directly with x, is telling us y equals k times x. The second part, y is 42 and x is 7, is saying we can plug in 42 here for y, and we can plug in 7 for x, and we can now find z. And we can now define this relationship a little better. Or not z, but k, I should say. How do we find k here? We divide by 7. 6 equals k. So what that means is the true relationship here is y equals 6 times x. And we can take that a step further. We can write y varies directly as x, and y is 36 when x is 9. Find y when x is 7. So now there's a third piece here, but we still got the first two pieces look the same. Y varies directly with x. It means y equals kx. Y is 36 when x is 9. So where does the 36 go? For the y. And 9 goes in for x. Then we will solve for k by divided by 9. So 4 equals k. What's that tell us? Y equals 4x. And now we look at this last piece. Find y when x is 7. Well, you just put 7 in for x. What's 4 times 7? 28. So y equals 28 when x is 7. So if we know that two things are related in a certain way, and we know one pair of numbers, we can find other ones from that. This is what we would call, sometimes referred to as an initial condition. So you know the relationship and you know an initial condition, so you can use that to create a formula. That's what we did here, is we created this formula from the relationship and that initial condition. We might have y varies directly with square root. of x. And y is, let's see here, 21 when x is 9. Find y when x is 25. So this is going to be slightly different. It's not y varies directly with x, it's y varies directly with square root of x. This is y equals k times the square root of x. Y is 21 when x is 9. Well, what goes in for y? 21. And for x, of course, is 9. There's an intermediate step we have to do here. Yeah, the square root of 9 is 3. So y equals 21 equals k times 3. And then divide by 3. 7 equals k, which tells us y equals 7 times the square root of x. Find y when x is 25. Well, we put 25 in where the x is. So it's 7 times, what's the square root of 25? 5. So 7 times 5 is 35. Y would equal 35. Make sense? So how does this apply to you guys at all? Well, because let's say we don't know the roof slope of a house. But we want to build, we have this roof here has a 40-foot span. And we want to build a garage next to it with a 28-foot span, and we want the slopes to match. And we happen to know that the height of this roof here is 8 feet. And we want to know how high to make this roof, how high to make that peak. We're just going to set a ridge beam and make rafters rather than ordering trusses. So over here, this has a run of 20 feet. This has a run of 14 feet. We know if we're going to let y equal the height and x equal the run, we know that y is equal to k times x. And we know y here is 8 when x is 20. We can divide out the 20 to get that 0.4 equals k. So y is equal to 0.4 times x. We put in 14 for x. Y is going to be 5.6 feet. So this height has to be 5.6 feet. Does that make sense? Kind of? Yeah. Now I said this is proportional. When you have two conditions like this side by side, you could have just said, hey, 8 over 20 has to equal h over 14. And if you cross, multiply, and divide, 8 times 14 is 112, divided by 20 is 5.6. That works as well. That only works though if it's directly proportional, direct relation like this. Our other option is something called inverse relation. An inverse variation, when one number gets larger, the other number has to get smaller. So the forms for this, it can either be x times y equals a constant, or y is equal to the constant divided by x. If I tell you y varies inversely as x, and y is 7 when x is 4. what we have here, y varies inversely as x, is telling us we have that form of the equation right there, y equals k over x. Y is 7 when x is 4. It's telling us to put what in for y? 7, and of course, 4 for x. We can now find k, multiply by 4, 28 equals k. So that means our relationship, y equals 28 over x, is really the relationship there. Now, of course, we could go a step further. We could have y varies inversely as x, and y is 8 when x is 6. Find y when x is 16. Where do we start? Y equals k over x. Then we start worrying about the 8, right? So 8 equals k over 6. And then times 6, 48 equals k, right? Which tells us what? Y equals 48 over x. And then, yeah, find y when x is 16. So we put 16 in there for x. 48 over 16 is 3. Y would be 3 when x is 16. You can see x got bigger. X went from 6 to 16. Y got smaller. X more than doubled. Y was cut to less than half. You could run into y varies inversely as the square of x, and y is 8 when x is 3. Find y when x is, what do I want to put in here? 2. Tell me where to start. Perfect. Not square root. Y equals k over, it's not square root, it's just square of x. So x squared. Then what? Put in the 8 for y, the 3 for x. So y, 8 is equal to k over 3 squared. We got an intermediate step that we're going to do. So this is going to be 8 equals k over 9. And then times 9. So 72 equals k. Which tells us perfect. Y equals 72 over x squared. So find y when x is 2. So y is 72 over 2 squared. 2 squared is 4, so y is 72 over 4. So 72 over 4 is 18, so y is 18 when x equals 2. For you guys, where would this come in? Well, let's say that you guys have a sump pump that is 6 CFM, 6 cubic feet per minute. So that's capable of pumping. You have a rainy day. If you dug a foundation for a basement, you dug the basement, rainy night, and it fills up with water. So you hook up your pump, And you start pumping the basement. And it takes well, let's say that this pump takes 40 minutes to pump out the foundation. It's a little wet, so you let it sit. You come back, and guess what? It rains the next night. And you decide you don't want to sit around and wait for that sucker. So you decided what you're going to do is you found another pump that pumps 15 CFM. How long is it going to take for that pump to get this thing pumped out? Well, this is an inverse relationship. If the cubic feet per minute goes up, the time goes down. The pump gets bigger, the time gets smaller. So y equals k over x. We're going to let x be the size of the pump and y be the minutes it takes. So we have 40 minutes equals k divided by 6. We're going to multiply by 6 here. 40 times 6 is 240 equals k. So that tells us that y equals 240 divided by x. So if we switch over to the 15 cubic feet per minute, y equals 240 divided by 15, which is going to say y equals 16 minutes. So that'll be able to pump it out in 16 minutes rather than 40. Make sense? What's that?
So far.
So far? Okay. The next stage is when you start talking about combining variation. Now there's something called joint variation. Joint variation just means you have 3 variables. Joint variation, if they say y varies jointly with x and z, all they're saying there is y equals k times x times z. So basically y varies directly with both x and z is what that is saying. That kind of falls in a more general category. That's why I'm not going to spend a lot of time talking about joint variation. It falls in a more general category of combined variation. If I were to tell you that y varies directly with x and inversely with z. What that is telling us is that y is equal to a constant. Directly, the constant is multiplied by x or divided by x. Directly would be multiplied by. Inversely with z, inversely means the constant's divided by z. So y equals that constant. It varies directly with x, so it's x times the constant. Inversely with z, so it's the constant divided by z. Gives you that formula. Then you can do the same types of things. You can fill in values for x, z, and y, and find your missing values for k and get your relationship. And what I want to do is I want to get back to these guys over here for a little while. So I'm going to give you guys a worksheet to work on. See what you guys can work on. We'll come back. We've got an extra half hour with you guys at the end here. We'll come back in that extra half hour and we'll look at it in a little bit more detail. But on this worksheet, it's just 1 through 16 for right now. And we can come back and talk about it a little bit more in a little bit here.